I'm going to be helping you with some physics, and more specifically, acceleration. So, the acceleration of an object is defined as the rate of change of velocity. So here we have an example. A Bugatti Veyron can accelerate from 0 to 100 kilometers per hour, or 27.8 meters per second, in 2.46 seconds. Calculate its average acceleration. So first, we need to identify the equation you need. So here we have acceleration equals change in velocity over change in time, which can also be seen as v minus u over t. V being final velocity, u being initial velocity, and t being time. So then we need to substitute the values in. So we have v minus u, so v is 27.8 meters per second, which is our final velocity, and initial is 0 because it's starting from rest. And the t is 2.46 seconds. So we do 27.8 minus 0 over 2.46, which equals 11.3 meters per second squared, which is our acceleration. So then the car takes 2.34 seconds to stop from 100 kilometers per hour under braking. Calculate the acceleration. So a equals v minus u over t, which we've already found out, but this time our final velocity is 0 because it's stopped, and the u is 27.8 meters per second because that's where it's stopping from, and the time that it takes is 2.34 seconds. So we have 0 minus 27.8, or minus 27.8 over 2.34 seconds, and that will equal minus 11.9 meters per second squared. So the negative means that it is decelerating. So here we have some questions. The first question is, a racing cyclist starts from rest and reaches a velocity of 8 meters per second after 12 seconds. Calculate the acceleration of the cyclist. Stop now if you want to work out this question on your own. Okay, so what we need to do is find the equation that we need, which will be acceleration equals v minus u over t. And we find our values. So our a, we don't know yet. That's what we're trying to find out. Our final velocity is 8 meters per second. Our initial velocity is 0 meters per second because it's just starting from rest. And our t is 12 seconds. So we substitute that in. So a equals 8 minus 0 over 12, which also equals 8 over 12. So a equals 0.75 meters per second squared. So our second question is, a train slows down from 40 meters per second to 10 meters per second over 60 seconds. Calculate the magnitude of deceleration of the train. Stop now if you want to try out this question for yourself. Okay, so first we've got to find our equation, which is again a equals v minus u over t. So we find our values. So a, we don't know that yet. That's what we're trying to find out. V this time is 10 meters per second because that's what it goes down to. Initial velocity is 40 meters per second because that's when it starts braking, or when it starts slowing down. And our time is 60 seconds. So we substitute that in. So acceleration equals 10 minus 40 over 60. So that would also equal minus 30 over 60. So the acceleration is minus 0.5 meters per second squared. So this is decelerating. And that's how you do acceleration. So I'd like to thank you for watching this video, and